Guys, my name is Rohit Singh. Welcome to the channel Developer Geeks Hub. Well, this video is all about questionnaires. Well, this is the current playlist for C++ programming, and we are trying to cover topics such as for beginners, intermediate, and experts. You can check our previous videos on C++ in the I button. Well, this video would be a little longer video than the usual because we will try to cover and solve practically as many problems as we could, because these problems are actually asked in your college examinations and assessments. So to understand it you have to understand practically that how the data works, how you can create a function. And you can see the questions in your screen right now. These are the top 5 and the remaining 5 are like a moderate. This is basically a low level for right now if you are a beginner, because and you have to understand this because sometimes you would be asked in your interviews, because they don't ask much of a crucial question. They sometimes ask a tricky and a medium level question to see how strong your basics are. So now let's jump into the C++ compiler and let's see how every single program works. Well guys, the first program is to read and display different names, address and phone number. Now let's create data type for it. We will remove these. First is the name, right? So there is something called as string data type. We will name it as a name. The data type is string and the identifier is name. Then we will create address to it. Address is another variable, and then the phone number. We have an option that we can write the phone number in the string value or in integer value, but I think we would prefer phone for string. Now what we will do is that we will write a cout statement that would say enter your name here. Then after we will write an endl, then termination, and we will take the name. Then we can copy this whole thing and we can paste it twice, and then we will write address here and phone number. Superb. And instead of this we will write address and phone. Superb. And we will try to print name, address and then phone number and then an endl. Now let's try to print this. Enter your name Rohit, enter your address Gokul Dham Society. Okay, phone number here. Okay, actually I've written a space here that I have to ignore, so we will compile it again. I will write Rohit Gokul Dham 932 and the number, and you can see it is printing everything. Now let's customize a little. What we'll do is that we'll say cout. In the next line, when we get the name, we will write welcome, and then after we'll write his name, his or her name, and then after welcome welcome example Rohit to our website, and then after that's done. Now write please enter your address here, I think it would look a little professional now. You can see, enter your name here. Welcome Rohit to our website. Please enter your address here. Address is Gokul Dham. Yeah, that's it. Gokul Dham. Yeah. Enter your phone number. Random numbers. Okay, actually I've removed this. See out. Address is address, and then see out. Address is, sorry, phone number is phone, and then enter. So I think this would look a little professional. Rohit, welcome Rohit to our website. Write your address. Gokul Dham. Write your phone number. Some random numbers. You can see the address is Gokul Dham. Your phone number is blah blah blah. So guys, this is how you can take values and you can manipulate the data, like I have done in this line. Well, the next program is to read and display the largest of three numbers. So first what we will do is that delete this thing. We will take three numbers, int a, comma b, comma c. Then we will ask cout from the user and enter three values here. Then we will terminate this and we will ask three values, that is a, b and c. Now what if a is greater than b and a is greater than c? So what we will do, we can say that we can say that the value of a is greater, yeah. So and we can write this too. Now what if we have to write all the different conditions over here, guys? Now what else if b is greater than a and b is also greater than c? Now instead of this we will copy this and paste this and we will write b is greater now, and we can copy this whole thing and paste it, and instead of b here we will write c, and we will write c here too. We will remove one greater than symbol and we will compare it with b again, and if c is greater then it would print c. Superb. I think this should work now. Now let's print this and let's enter three values like 18 1 to 8. Okay, 1 to 8, then 920, then 2738. So you know that within these three numbers which number is the greatest one, that is this one. Now let's see that this code does work or not. Yes, it is working. You can see that it is printing 2738 is the greater. So what concept that we have used here, you guys have to comment down in the description below. Well, the third program is to write and display from a given number that it is a prime number or not. Basically, a prime number is something that is divisible by itself and it is divisible by 1. So what we can do is that we can create a for loop from before that for loop. What we'll do is that we'll create an int a and we will ask the number from the user, enter the number, and then after scene a. Superb. Now what we'll do is that we'll create a for loop from I is equal to 0 till I runs A. Yeah. Then after we will increment I plus plus. And within this, what we will do is that if, okay, we won't write I is equal to 0, we will start from I is equal to 2. Right, what we will do is that if a percentage I is equal to 0, then what we'll do is that we will create a flag. There is a concept called as flag. We'll create a boolean value of flag is equal to true. Right, if this situation occurs, then what we will do is that we will change the value of flag to false. You can see this is the for loop, and within that there's a condition, and then after there's another condition. If this there's a statement within this condition. Right, now after that we will do is that again if condition, if flag is equal to true, you can say that it is a prime number. It is a prime number. The reason is because you can see if this condition is true, it means that it is not a prime number. There is some number I which is between 2 and A, which is making this A divisible, because the percentage is nothing but 0. So if it is true, it will make the statement false. So if the statement is false, it means it is not a prime number. If the statement is true, it means it is a prime number. Now let's check that our theory is right or wrong. Else, we can say else. Else, and then a cout statement. It is not a prime number. Now let's try to run this program. Okay, there is a okay. I've forgotten to write the double quotes, which is important. Now let's try to write and check the number for 7. So we know that 7 is a prime number, right? Now let's see what would be the output. You can see it is printing that it is a prime number. Now let's try for 6. You can see it is not a prime number. Let's try for number 9. 9 is a non-prime number. You can see it is a non-prime number. Let's try for 11. You can see it is a prime number. So our program perfectly works. Now let me introduce to a topic or a concept called as a ternary operator, which is a very important thing. Basically it includes basically ternary means 3, right? It means 3 operand, right? What we can do is we will write the condition first, that if flag is equal to true, and then a question mark. What we'll do is that cout prime and cout prime and not prime. That's it. I think we don't have to write this too. So if we try to run this, you can see it has run successfully. If I write 7, so is 7 a prime number? Yes, it is. So you can see it is printing prime. Now let's try for 90. 90 is a prime number? No, it is not a prime number. Let's try for 23. Is it? Yes, it is. It is a prime number. So our ternary operator also works. Basically what a ternary operator means is that we have to write a condition here. If this whole condition is true, so it will ask, this question mark is basically a if else thing, right? So if it's true, it will go to this first half of this semicolon. It will do whatsoever it is asked in this first half. Then after, if this is false, it will go to the second half. So guys, this is how a ternary operator works. Now let's create a function to swap two numbers. Basically swapping is nothing but, suppose there are two variables. If a variable is having a value and another variable is having certain value, so what we have to do is that we have to exchange their values. So for this we will create a function. Now let's create the function and name this as void swap, and we will use some concept that you have to comment down in the comment section, that which kind of concept we have used here. Okay, then what we will do is that we will create two variables, a is equal to 10 and b is equal to 20. Super. Now what we will do is that we will call the function swap and we will pass the values a and b, and then we will print a and b. Okay, before calling this function swap, what should it print? You can see it is printing 10 and 20. The reason is because we have not swapped yet, right? So we can say that before it is printing this value, or else what we can do is that we can copy this, and before calling the function we can say that before swapping, and we can say that after swapping, right? After swapping. So let's try to try what should we do here, and in this we will create an integer called temp, right? First what we will do is that we will assign temp is equal to a, then after we will write a is equal to b, then after b is equal to temp. Basically temp is a temporary variable we created so that we can save the value of a to here, right? So the value of a is 10 now, right? So 10 is saved in that temp variable, and then in the second line the value of b is saved to a. Now the value of a is 20 and the value of b is 20, so both are having the value 20, and then after we are changing the value of b by using the temporary variable that we created at the beginning. So the temp value is 10 and the b is changed to 10. So guys, after this line we can say that the value have exchanged, right? Now I think they're working properly. Now let's try to print and see what is the result. Yes, you can see that we are successfully able to swap the numbers. You can see a and b are as it is, but the values have changed after this swap. So guys, this is how we can create a swap function. Now you have to comment down in the comment section that what kind of concept is this, how I called this variable, what is this ampersand symbol. You have to comment everything in the description. Now let's see how you can print a Fibonacci number or a Fibonacci series. Basically Fibonacci number is nothing but, if the first and second number must be 0 and 1, right? And the succeeding number would be the addition of the preceding numbers. For example, the first number, as I said, is 0 and 1. So the succeeding number would be the summation of the previous two. So the succeeding number would be 1, and then the addition of this 2, that is 2, then 3, then 5, then 8, then 13. Similarly it will go. So the what you have to do basically is that you have to take an integer n from the user, right? And you have to write that enter the value of n, and enter the value of n, then you will take the value of n. Basically n is nothing but for how many times you have to print the numbers, right? So firstly what we'll do is that we'll create f equal to 0 and s equal to 0, sorry, s is equal to 1. Basically f means the first number and s means the second number, that is 1. Then after we'll create a for loop for int I is equal to 0, I is less than n, and then I plus plus. So what we will do is that we will add, okay, we will add these two, and then after we will print, right? So we'll create a third variable int c is equal to f plus s, and then after we will print c with some gap, and then after we will change these values. What we will do is that we will assign the value of f to s and then s to c. Super. This for loop will run again and it will go through the same thing, and it will print the value of c until and unless it reaches the value of n. But before that we have to print f and s first. Now let's see that our program works or not. We have to print for the first 5 numbers. You can see it is printing for the first 5 numbers. Actually this 2 are printed by this statement itself, so we can neglect that, and you can see the remaining 5 numbers are the Fibonacci series. Instead of, let's try for bigger number like 9. You can see it is printing for the next 9. You can ignore this 2. So these are the next 9 Fibonacci series. Let's check 21 plus 34. Yes, it is 55. 13 plus 8. Yes, it is 21. So our program actually works. What we base, the ideology behind this program is nothing but the value of f is 0 and s is 1, because Fibonacci starts from 0 and 1. That is the basic idea. Then after you will create a int c and you will add these two and you will print that. So you have added these two and you have printed this in here. Then after what you will do is that you will change the f to s. That means this one, the variable f would have this value and s would have the new value, that is this value, and then after it will again add and will be saved in C, and it will print C, which would be this, and it will keep on exchanging the numbers to back to f and c, and it will keep on adding in the series. Well guys, now let's see how you can create a calculator by using switch cases in C programming. Now first, what kind of operation we will do is that we will do addition, we will do subtraction, we will do multiplication, we will do modulus and divide. The top 5 basic arithmetic operation we will do. Firstly, we will ask from the user, enter your operation. Then after we will add a semicolon here. Then after we will take the value OP, and we'll take a character OP, right? So the user will take the operator here, and then after within the switch case we will write OP, and the cases would be basically case, addition, semicolon. Similarly, we can copy that and we can add more 4 times, and then after, yeah, so we will change all these operator modulus. Then after, what we will do is that we will create 2 numbers, int a comma b. This a comma b would would be our 2 numbers, right, that we have to add. If the user selects addition, then we will write cout, enter the numbers for addition. Super. Then after, we will take the values a and b. Then after, we will rent sum is sum of, we can make it a little beautiful, a and b is what, a plus b, right? So what we can do is that we can give it a little space every single in every single string, and after this we can give a tab, and then after, one of the important thing is that break. You have to give break, otherwise it will go in the next section. Now let's copy this whole thing, and yeah, actually forgot to add the default statement. If suppose the user enters something that is out of the cases, then we can say that you have chosen some wrong option, or there's no operation for this particular operator, right? No operation valid. Now we can copy this whole thing and we can keep on adding. Yes, it is looking great. Now let's give spaces between them so that we can understand it clearly. Yeah. Now let's try to run this program. You can see it is built successfully without any errors. I hope. Okay, actually I've forgotten to write for the different operators, for subtraction, for addition, then for the multiplication, and then for the division, and then the modulus. Super. Now let's try to run now. Okay, enter the operator. Suppose I have to do the multiplication, the division operator. So it will write, actually I have to change this to subtraction, multiplication, and then division, remainder. So okay, now let's write subtraction. You can see it is writing that enter numbers for subtraction. Suppose I write 12 and then 6. So we know the answer should be 6. Now let's see what would be the answer. Superb. You can see these okay, we have to change this sentence too, but you can see the output is coming right. So you can change it to answer. Okay, so for let's try for division. So we can see enter the number for division. We will write 24 and then 6. So we know what should be the answer. Now let's see the compiler is it giving right or not. Yes, it is. You can see So guys, we have successfully built a calculator, a simple calculator using a C++ programming with some basic operators. Now let's see what is an Armstrong number and how we can check that a given number is an Armstrong number or not. Basically, if let me delete this on code. So basically, Armstrong number is nothing but when a given number, suppose 523, right? If we cube the every single number that and sum it up, suppose 1 2 3 is a number, right? And if we suppose cube every single number and then we add the resultant, it should be equal to 1 2 3, right? So let's see how you can divide the numbers and let's check how you can start the code. First is that you will take an integer n, then enter the number here and n semicolon, then cin. You will take the number from the user. Now then after, what we will do is that basically we will use many operators here, starting with, suppose, let me tell you an example. Suppose int c is equal to n percentage 10, c out c. Now if I run this program, okay, yeah, if I run this program, so what will happen, what will exactly happen in this would be that, suppose if I enter 89, then you can see the last number is printed, right? So this percentage 10 basically helps us to divide every number, right? So similarly, what we will do that is that we will do this in the same fashion, and we will try to cube it up. Now what is cube? Cube is basically nothing but a into a into a, or else there is a predefined function in the math library that even that we can use, but I think I will cover that in the next topic. Okay, so firstly we will take an integer sum, because sum is, and we will make it to 0. So sum, because sum is something that will save the summation of all the cubes, right? Then after, what we will do is that we will take another variable c, and then after we will divide that c with 10. Then after, so so we would be left with the last digit, right? Then what we will do is that we will add this sum is equal to sum plus c into c into c, right? Superb. Then so if suppose there if it's a single digit number, right? Let's try this code for a single digit number, suppose 7 or 4. So what is the cube root of 4? 4 4s are 16, and 16 4s is nothing but 64, right? So it should print, okay, I'm not printing anything here. Let's give the output sum here and let's see is it working or not. Yes, you can see it is working for 64. What if we have two digit numbers, right? So after doing this n percentage to 10 and cubing this number, then after, what we will do is that we will change the value of c is equal to c divided by 10, right? And this whole thing would be in a while loop, and the condition for while loop would be c should not be equal to 10, and we can initialize this c outside the so so you can understand. Okay, C should not be equal to 0. Yeah, so first we will percentage it, or you can say we will take the last number here and save it in the C and cube it and add it in the sums value. Then after we will divide this value here, and then after we will keep on doing the same thing. Now since you can see that we have the original number itself, the original number is not hampered, right? So what we can do is that after this, after everything, you can check if the value of sum is equal to n or not. If it is, then we can say it is an Armstrong number. Superb. Else we can say that it's not. It is not an Armstrong number. Now let's run this program and let's see for 1 2 3. 1 2 3 is basically not an Armstrong number. You can see it is printing it's not an Armstrong number, but 1 5 3 is an Armstrong number, right? So you can see that it is printing it is not Armstrong number, but actually let's see what is wrong in this code now. First we have taken the last number, that is 3. Then after we are saving this in this number, then we are cubing it and adding to sum. Then after we are dividing the value of, okay, we have to divide the value of n actually, not C. And because yeah, it should work now. And we will take another integer r because it is saving the remainder, right? And instead of n we will take C here. Then after we will we can do this now, but instead of C we will we will multiply r and we will save that in this sum. Then after what we will do is that we will divide the value of C by C. Yes, I think it should work now. Yes, if I take 153, you can see it is working properly. There's another Armstrong number. There are many Armstrong number. Let's try for 513, 512. You can see that it is not printing now. So guys, this is how you can create an Armstrong. You can check that a particular number is an Armstrong number or not. So this is a famous method that how you can check for individual numbers and then keep on incrementing from the right to left. And this is called as the copying or making a temporary number, right? So that the original number is not hampered. Well guys, now let's see how you can print the sizes of the memory that a particular data type consumes. Basically, let's create data like int a, then after float b, then character c, and then string d, double e. Okay, the spelling of double is wrong. Then after double, okay, unused variables, yeah, the unused variable. Then after long, f, okay, long f, and then short h, and then int float character boolean. Okay, so we will print the values now. The size. So there's a function called as the size of. So we can use that function and try to print the values or the data, the memory that every single is storing. A, B, C, okay, B, then after C, then after D, E, F, G, Now let's try to run this code. Well, you can see guys that integer is taking 4 bytes. All these value are in bytes, right? So why integer is, in many books you will see 2 bytes and 4 bytes. Actually it depends on the compiler or your PC, right? That if your PC is 32 bits, it would show 2 bytes, and if it's for 64 or more, then it would show 4 bytes. Now for float it shows 4 bytes, right? Then after character takes only 1 byte. A string value, a string data type takes 24 bytes. This also varies sometimes according to the compiler. Then double takes the double of the float, that is 4's double, that is 8. Long basically takes the double of integer, that is 4. And then short takes half of the integer, that is 2. And then boolean is either 0 or 1 or true or false, therefore it takes 1 byte. So guys, this is how you can print the sizes of different data types. Either you can, instead of using variables, you can write int here, you can write you can write float here, or a character here, right? So for this also it will print the same thing. Well guys, now let's see how you can check that whether a given character is a vowel or a consonant. Now let's create a character A and then ask from the user for its input. Enter the character. Super. C in A. Now you can see that the user has given the input. Here it is saved in the variable A. So now we have the character. So what we have to do, we have to check that is the character and vowel or not. So what we will do is that we will write an if condition, that if A is equal to A, or A is equal to E, or this is called as the logical OR. Basically logical OR is nothing but in every, if suppose there are two statements, right? So if either of the statement is true, the whole condition would become true, right? So that is what we have to use here. There's another kind that is called as the logical OR. In that every single statement should be true, right? So that is not the condition that we want. We want any one of this condition has to be true, right? So A, E, I, O, and then U. Super. Or we can copy this whole thing and paste it in here, because we have to consider for the capital letters too. A, E, I, O, U. Super. So if this condition is true, people, then what we will do is that we will tell the user that the entered value is a vowel. That is A. If not, then we can say it's a consonant. The entered value is a consonant, that is A. Super. Now let's try to run the code. Okay, we will remove this here and add the single quote here. You can see it has run successfully, it has built successfully. Now let's try to write O. Is O a vowel or consonant? Yes, it's a vowel, and you can see that it is printing that O is a vowel. We will write end L here to differentiate the outputs. Okay, now let's try for capital U. You can see it is a vowel. Let's try for P. You can see the entered value is a consonant, that is P. And let's try for a number 90. You can see it is printing the entered value is a consonant, that is 9. It is not checking this values because it is considering this as a null value, because character only takes the only one value, right? So it will ignore the remaining values. If I supposedly write UP, right, then you can see it is taking the value of U and ignoring the value of P, right, and printing the value that it is a vowel. It is not an error, guys, firstly, right? Now let's try for special character. You can see it is printing this as a consonant because we have not mentioned, actually it's a symbol, it's not a consonant, right? So if we partition it a little more, right, rather than writing else here, we can write suppose else if a is equal to a number, right, for 0. Basically in the back end, what is happening is that it is converting these these character into ASCII codes, right? So what we'll do is, if a is greater than equal to, or a is less than equal to 9, so it should say that digit, right? Now let's try to run this code and let's try to write 8. You can see it is printing that the entered value is 8. Let's try it for more vibrant, like 1. You can see the entered value is 1. Therefore this is how we can partition the if else ladder, and this is how the characters are checked by using the OR operator. And this is how a range of number, basically this is the range, right? I have entered that a can be less than equal to 0. Now what is this? You can see that this is a character, but in the back end it has some ASCII value, right? This would have actually a, if I'm not wrong, is the ASCII value of a is 65. Then similarly b would have the value of 66. Similarly we will increment 1 for every alphabet, so on, right? Similarly 0 is having a unique ASCII code till 9. So that's the reason it is a range, right? And within this range, if your character falls, so it will print this statement. So guys, this is how we can create and check that a given value is a character or a vowel, a vowel or a consonant. Well guys, now let's check that a given number is a palindrome or not. Firstly, what is a palindrome number? Basically palindrome, if I give an example, suppose 1 2 3 1 2 3 and 1 2 3 3 2 1 1 0 0 1 0 and 1 0 0 0 0 1. Okay guys, so you can see that I have written 4 numbers here. Now palindrome is something that if you read from the left side or if you read from the right hand side, it should be same, right? Or else I can put this in the way that if you reverse the whole number, then it should be the same. It should not change at all. So this is called that checking of a palindrome number. Now let's see how we can do that. Now let's take the value from the user. Int n is equal to int n, that's it. We'll take enter the number to check its palindrome. Super. Then after we will take the value from the user n. Now what we will do is that we will create another integer called rev, that is reversed, and rem, reminder, and then we will we will take another number c, or we can take original, right? Original value is nothing but it will save the value of n. Now original will have the value of n. Then after we will create a while loop to run the code till the value of n is doesn't become 0, right? Now what we will do is basically is that we will try to the original value will have the original value. Suppose if I write 1 2 3 3 2 1, so 1 2 3 3 2 1 will be in the original value, right? And we'll manipulate, we will try to reverse this n. Now how we can reverse this n is that we can take the value of reminder, and we can percentage, we can say the last value in the reminder, right? Then after we will take the rev, that is the reverse, and then we will reverse this and multiply it with the value of 10. Initially I will take it 0, and then after I will add the reminder to it. Now the reason is because suppose the value suppose I am the entered value is 1 to 1, suppose, right? So first what will happen, n by 10, that is nothing but this value of 1 will be saved here, right? And you can see 1 is here now. Now rev, that is 0 now, so 0 into 10 is nothing but 1, so rev will have the value of 1. Then after what we will do is that we will divide n equal to, or this is called as a shorthand, people. Now we will divide the value of n by 10, that is if I divide this, so it will have this number. So now 2 is gone. Now the value is, and the value of n is 2, right? Sorry, the value of n is 12, right? It is neglecting this because it will, if I divide 121 by 10, it will have 1 to 1.1. Since it's an integer value, so it will ignore the float values, right? So in the second iteration, that is when the while loop goes again, so it will check for 12. Is 12 not equal to 0? No. Now it will divide with 10. Now it will have the value of 2. Then what is the value of rev? Rev is nothing but 1, right? So 1 into 10 is 10. 10 plus 2, that is 12. So it will do the same thing and it will reverse the string eventually. Now what we can do is that we can check if original is equal to reverse. If so, then we can say it's a palindrome. Else we can say that it's not, or else we can say that original is a palindrome, or original is not a palindrome. Super. Now let's try to run the code. You can see it is printing, it is asking for the number. Now let's try for number that are not palindrome, like 123. You can see 123 is not a palindrome number. Let's check for 454. 4545. 4545 is not a palindrome. Yes, it is not a palindrome. Now let's check for 1001. Is it? Yes, it is. You can see it is printing successfully that 1001 is a palindrome. Let's try for 123321. Yes, it is a palindrome. So what basically we did is that we created a while loop, and we took the the value of rev, and we kept adding the values and the reminder itself, right? And we tried to, this whole code, what it is doing is that it is just reversing the number, right? If it, suppose if we pass 1 2 3, So it will change it to 321, this whole thing. Well, that's it from my side, guys. If you find this video informative, then don't forget to like, share and subscribe to our channel. Well, in the next video, we will understand different libraries, starting with the mathematical library, or we call as math library. We will see what are the different functions which are offered by this mathematical library, and we will try to implement most of it. Well, we will see you in the next video. Stay tuned.